Now, to extract the beams that we want for getting all of this information into Maestro, there is a script that comes with Maestro. So if we go into Tools, Rhino Script, Load, the one we would be interested in is this one, Export Maestro Beams. Now it does more than just export the beams, it also extracts them from the mesh. So we'll load this script, and it presents multiple options of what you want to do. Polyline and direction allows you to select a group of polylines and specify a direction for the web, and it'll export those polylines as beams that can be read into Maestro. The other one is polyline on mesh, which takes a series of polylines, and then you give it an associated mesh, and the polylines have to be created from corresponding nodes on the mesh, but it'll use the mesh normal to specify what the orientation of the beam web is. There's also this polyline on mesh restricted to a plane, and this is useful for if you're exporting your frames. You may want, if you have a lot of curvature in here, or the frame wraps down the full length of the hull. If you're not doing deck by deck, or at the lowest level, you have a portion of the frame that's on the vertical side and a portion that's on the bottom. You could probably pick about a 45-degree angle so that they're all pointed towards the inside of the hull, but some are a little bit skewed. They're not perpendicular to the plate. So what you can do is tell it, I want it to be normal to the plate, but restrict it to either the constant X, constant Y, or constant Z. So that's handy for writing out frames. Mesh and direction polylines is to extract the beam traces from the mesh, but it only creates the polylines. It doesn't do anything with them, won't export them. Mesh and direction beams will extract the polylines from the mesh and run the export command. And then this last one, mesh direction and seed, the idea behind that was to select the mesh and direction and a number of seed points, and it would extract beam traces based on those seed points from the mesh, but that one hasn't been implemented yet. If you try and run that one, it just tells you not available, but the other ones are. Now there is an entire video explaining this as a tutorial on the Maestro website, and there are two actually on the website there. I don't know if you may have looked at these over the past several days or not, but if we go under the video tutorials here and we scroll down to exporting beams from Maestro, there are two, and it's the second one, I believe, exporting beams from Maestro using Rhino scripts. The first 20 minutes are the exact same thing, and basically the first 20 minutes goes through each one of the different options of what this script does, and it shows you an illustrated example. This second one has, let me mute that, it goes through and does the examples of how this script works, and then it does an illustrated example on the hull, that deck sample that we were looking at before, and it explains what some of the things to look out for are when running this script and so forth. And portions of it are accelerated in there. You saw real time ×4 because as it was marching through doing some of the portions of it were a little slow, or if I was doing a lot of operations, I just sped up the graphics to save some time. But this goes through and you can see where we have frames, stiffeners, and so forth. But that's a good reference for executing the beam extraction portion. And we'll do that now. So we'll go ahead and we'll load this script, export Maestro beams, and I like to use just mesh and direction polylines because that creates the curves and allows us a chance to edit them before we export them to Maestro. So we'll start off with the main deck. It asks you to select some meshes to extract the beams. So we'll just do one as a start. And once you hit enter to finish the selection of meshes, you select a base point and a direction. So we're just going to go straight longitudinal along the x-axis, and then give it a beam tolerance or a direction tolerance. So as it searches through the mesh, it'll find every edge that is within this angular tolerance of the direction you specified, and extract those edges, and then it'll join them into curves. So since we know this is all of these are essentially perpendicular to the center line, with the exception of some shear in the forward portion of the deck, it does slope upward. So if we were to set a 0.001 angle or something, it might not find some of these portions that have shear. But we'll just use 5 degrees, and you can type in a specific angle if you wanted. I could have typed in 8 as the number of degrees, and these are just some pre-selected ones if you want to just for a quick selection. And it'll take a second as it searches through, and it just extracted all of these candidate beam traces. Now, it's also going to select some that you're not going to want, such as the deck edge. So we can select that deck edge and delete it. Select the curves here. Unfortunately, I have all my bulkhead curves still turned on. So now I think we just have the deck curves here. And this is where I created a separate layer underneath the decks called beams, and that's where I put them. So I'm going to move those under beams, and what I like to do is display them in a different color. So I'm going to change those to red, make it a little easier to see where they are on the model. Now, at this point, if you had longitudinal bulkheads in here, you could go in and delete some of the nodes or some of the portions of the lines here where they would interfere with the bulkhead. Also, you may not want some of these, you may want to terminate some of these close to the shell at a corresponding frame. Now, we haven't extracted the frames yet, so let's do that now. We'll grab that same deck, we run the same script, and we tell it to generate the polylines, and my base point is going to be transverse. Again, I'll use a narrow angle, and it grabs all of these lines. Now, what I should have done, but forgot to do, was to group all of those other, the longitudinal stiffeners into a group. Makes it a little easier when I go to select curves for deleting afterwards, because obviously I don't want all of these as my frames. Now, when they get extracted, they're all still in the selection set here. In order to just pull out the ones corresponding to frames, there's another script called select curves constant X. And what this will do is find every curve that is has a constant X value using whatever increment you specify. So we tell it, wants a reference point, so we'll use 0 for the origin. And then the X interval of the curves that we want to save. So I'm going to say 2 meters because we want a frame on every other meter. And it runs through and throws out any curves that are not on that X increment. So here are all of the lines corresponding to the frames that I want. Now, obviously, some of these are going to have an issue because there's a bulkhead there. So I'm going to unselect those that interfere with the bulkhead. The rest are going to be frames. So I will put them in a group. My longitudinal curves, I wish I had created them in a group, because then what I could do is select curves, and I could unselect my frames. And if I had done that, I could unselect longitudinals, but I can do that fairly easily here. And well, we have all these bulkhead beam traces, but I'm going to go ahead and get rid of all those right now. We'll just delete all of the curves. So now we have our deck, longitudinals, and versus make them easier to select later when we go to export. Group them so we can easily select all of our deck stiffeners. We can easily select all of our frames. Now, even when they're grouped, you can turn on the control points. And this is where I would go to edit them. Hide my frames. No, they're still there. If I turn on the control points for all of these curves, in order to shorten them, yeah, I can't highlight them, okay. In order to shorten them, you can select a control point and delete it, and the remaining curve is still there. It's just not showing up my deck very well, so I'm just going to turn that off for now. This isn't particularly helpful either, but you can see which of these curves are extending beyond frames so that I can terminate these curves. Did group definition for the stiffener, so I'm going to recreate that. So when I turn on all those control points, I can see which ones extend beyond frames and just trim them back a little bit. And this I had already done in the other model, so I'll leave it at that. Turn the now for bulkheads, I would extract vertical stiffeners and then just manually add in those, like that little intercostal at the bottom there, because it's just a fairly easy to create a polyline there. For the shell, and you can select multiple meshes if you want, or join these all into a single mesh when you go to run the script. Now, if they're pre-selected, it doesn't bother asking you for selecting the meshes. And I'll do polyline and direction. And you can see some of these come in at a pretty steep angle that I want to extract, and they wrap all the way around, and they're coming into the transom at another angle. So I will turn off ortho, and I'll pick something that kind of bisects the range of angles that I want to cover. And I'll use a very large tolerance here, and let's go with 65 degrees. Let's see what we get. And it's not bad. That's pretty close to what I wanted. It missed a couple up in the bow, but got most of them. Got a few extras that we didn't want. You can see along the stem here. I'm not sure which one that's connected to, but we can start removing the ones that we want to keep. That deck edge at the top. These for now. The stem is going to go. So that really just pared it down to the stem and extras here. So to complete these last ones, what I would do is just manually create a polyline, and I want to limit it to selecting a vertex. Now, most of my curves are already turned off, so it's not a big deal here. But if you had other geometry turned on, you could limit your selection to vertex and then simply create the missing pieces of the stiffeners here. And then select all curves. Since they run parallel to each other, we can go ahead and join them, and they should get merged back together. Now, a couple of them down here, you can get some odd connections. That obviously is not the stiffener trace we want. So the easy way to correct these, and this is kind of a handy thing to do, is to just explode the polyline, deselect something to break it, and then rejoin it. So our traces are pretty much intact. And now we have these two little extra curves to delete. Now this one is a little odd, but it's the end of the curve that we want to get rid of. So what I can do is just select these three curve points and delete them. And that leaves me with just the curve that I wanted. Now, when you go to extract curves on the deck, you may have a bulkhead underneath where you want to delete part of a stiffener, but you want to keep a portion before it and a portion after it. So if we extract these curves, just create the polylines again, and I'll set ortho on. Fairly tight tolerance. We have our curves there. And you can see this curve is going to interfere with our bulkhead. So the way you could do it a couple different ways. You could do the explode and break it here, break it there, rejoin. Just select this piece of curve and delete it. You could also delete all of these endpoints or all of these curve points that interfere with the bulkhead so that you'd have the appropriate polyline coming back to the beginning of it, one long segment along the length, and then the rest of the polyline aft, and then do the explode, unselect, and join, and then delete that one long polyline. There's a couple different ways of doing it. It's whatever personal preferences, but it's sometimes easier to modify these bulkhead or modify these beams before you export them,